Hello students, you all are welcome in grade 7, subject science, chapter number 14, electric current and its effect, video number 2. Our topic today is heating effect of electric current. Start from activity number 14.2. Open page number 163. Take an electric cell, bulb, a switch and connecting wires make an electric circuit as shown in figure 14.9. This activity has to be done using only one cell. Keep the switch in the off. You see the figure 14.9. In the off position, does the bulb glow? Means just now we have seen, I have just showed you the figure. So touch the bulb. Now move the electric switch on position and let the bulb glow for a minute and so. So again touch the bulb. Do you feel any difference after moving the switch back to the off position? Touch the bulb again. So what do you observe in 14.2? The bulb will be heated. Correct? When your circuit is on, something heat is produced. Now you see activity number 14.3. Make a circuit as shown in figure number 14.10. Like this way. This is figure number 14.10. Here you see this circuit diagram. Take 10 cm long piece of nichrome wire and tie it between the nails. You can get the nichrome wire from electric repair shop, or you can use a piece of discarded coil of electric heater. Touch the wire. Now switch on the current in the circuit by moving the switch to the on position. After few seconds, touch the wire. Do not hold it for a long time. Switch off the current. Touch the wire again after few minutes. You see here some precautions you have to do it. Do not keep the switch in the on position for a long time. Otherwise, the cell may become weak very quickly. Okay. Now, these type of heating effect also you can find in mobiles also, right? That after sometimes when it is charged or once it is charged, or when you have whatever the adapter is there, when you touch that adapter, you can find that heat. You can feel the heat, right? So this is the heating device. Now the wire gets hot, and when electric current pass through it, this is the heating effect of the electric current. So can you think of any electric appliances where the heating effect on the electric current is used? Make a list of such appliances. Number 1, here you see, this is electric furnace. You might have seen electric room heater, right? Or electric heater which is used for cooking. Then electric iron, right? You might have seen some electric room heater or electric heater used for cooking. All these contain a coil. All these contain a coil of wire is there, and this coil of wire is called element. So you may have noticed that when these appliances are switched on, Bujo could not see the elements in an electric iron. Paheli told him that electrical appliances such as immersion heaters, hot plates iron, geyser, electric kettle, hair dryers have elements inside them. So have you ever seen the elements in any appliances? Here you can see this is the coil of electric iron. बराबर? आप अस्त्री करते हो ना कपड़ा को, उसके अंदर जो है ना वो इलेक्ट्रिक आयन को आप अगर खोलोगे पीछे से, यू विल फाइंड सच टाइप ऑफ कॉइल्स, राइट? तो ये जो कॉइल है वो हीट होता है, राइट? और वैसे वो अस्त्री का जो पीछे का जो लेयर होता है, बराबर, सरफेस, वो गर्म होता है, एंड यू कैन आयरन वेल. Here you can see the bulb. Inside the bulb, filaments is there, which is made up of tungsten material, right? After some time also you can find the bulb is heated. Why? Because it is heating device is there, right? Due to this long time when you on the switch on of electric current. So filaments become hot and you find the bulbs become hot. Okay. Now incandescent electric bulbs are often used for lighting, but they also give heat. It means that part of electricity consumed is used in producing heat. So this is not desirable. As a result, in the wastage of electricity, right? The fluorescent bulb, the fluorescent tube lights and compact fluorescent lamp, that is CFL, are better electricity which efficient light sources. Nowadays the use of, we are using which light? LED light, right? In that all the decoration materials and in car also. अभी LED का जमाना है, right? So LED means light emitting diode. Bulb as increasing, बराबर. For producing a given intensity of light, LED bulbs consume less electricity as compared to incandescent bulb or fluorescent tubes or CFL. Thus, LED bulbs are much electricity efficient and therefore it being preferred and cheap. ना कॉस्टली भी नहीं है और बहुत अट्रैक्टिव लगता है और इलेक्ट्रिसिटी लेस कंज्यूम करता है, पावर ज्यादा देता है, ब्राइटनेस ज्यादा देता है, राइट, और अच्छा लगता है. So it is advised to use electric appliances and gadgets which are electricity efficient. Bureau of Indian Standards, right, that is ISI, right, New Delhi assigns a standard mark on the product called ISI mark, Indian Standard Institute, right. So which is assurance of the conformity to the specifications given on the products. It is therefore suggested to use as ISI marks products. Note the fluorescent tubes and CFL contains mercury vapor, toxic in nature. Toxic means zahar, right? Right. So fluorescent tubes, wherever it damage our atmosphere because it contains mercury vapor and which is toxic in nature. Therefore, the damaged fluorescent tubes or CFL need to be disposed of safely. Here you can see the picture fuse, electric fuse. वो आप मीटर के बाजू में देखते हो आपके घर में, राइट. ये भी यूज है, वो टॉयज में यूज होता है, कार में यूज होता है, राइट. फ्यूज यूज्ड in electrical appliances. These both are heating device, right? So electric bulb gets heated to such high temperature that starts glowing. If a large current pass through a wire, the wire may become so hot and that it may even melt and breaks. But is it possible for a wire to melt and break? Let us check it out. Now in activity number 14.4, make the circuit be used for activity 14.3 again. However, replace the cell with a battery of 4 cells. Also in place of the nichrome wire, a tight thin strand of steel wool. The steel wool is commonly used for cleaning utensils and is available in grocery shop. If there are any fans in the room, switch them off. Now pass the current through the circuit for some time. Observe the strand of steel wool carefully. Note what happened. Does the strand of steel wool melt and break? Wires made from some special material melt quickly and break when large electric currents are used pass through them. So these wires are used for making electric fuses. In all buildings, fuses are inserted in all electrical circuit. There is a maximum limit on the current which can safely flow through the circuit. If by accident the current exceeds this safe limit, the wires may become overheated and may cause fires. So if a proper fuse is there in the circuit, it will blow off and break the circuit. A fuse is thus a safety device which prevents the damages to the electrical circuit and possible fires. Fuses of different kind are used for different purpose. Figure number 14.14 shows the fuse used in our house. Fuses shown in figure 14.15 are generally used in electrical appliances. We observe that that capsule type of fuse and that capsule type of fuse that we use in car and toys. We observe the heating effect of the electric current and learn how use it our advantages. Does the electric current have other effect also? Yes. Now this is MCB that in everybody's house, right? In your house, besides with the meter, we use different type of MCB, right? These days, miniature circuit breaker. MCB means what? That long form is miniature circuit breaker are increasingly being used in places of fuses. And पहले हम fuse use करते थे बड़े-बड़े, right? Before that, we use this type of fuse in our house. But nowadays, we use MCB, right? So these are the switches which automatically turn off when the current in the circuit exit the safe limit. वो पहले के फ्यूज में क्या था, फ्यूज हमको डालना पड़ता था, राइट. यहाँ फ्यूज डालने की जरूरत नहीं है. इन दिस एमसीबी ऑटोमेटिकली द स्विच विल बी ट्रिप्ड, है ना, एंड यू कैन स्टार्ट अगेन व्हेन द करंट विल बी नॉट इन लार्ज अमाउंट, राइट. सो जैसे करंट एग्जिट में होता है तो ये स्विच ऑफ हो जाती है, तो हमारे जो अप्लायंसेस है घर में वो बच जाते हैं, है ना. वी सेव फ्रॉम द एक्सीडेंट्स ऑफ फायर. सो यू टर्न देम. अभी जी बी ने, गुजरात इलेक्ट्रिसिटी बोर्ड ने तो ये कंपलसरी कर दिया, राइट, कि आपके घर के बाहर फ्यूज के बाजू में ऐसी एमसीबी होनी चाहिए, भले वो फ्यूज है तो एमसीबी भी चाहिए. सो यू टर्न देम ऑन and the circuit is once again complete. Look, this ISI mark on MCB also, you can see. We have to use ISI mark equipments, right? So that will be better. Now the next point, magnetic effect of electric current. Okay, in this how to prepare electromagnets, that we are going to see. And you have to also prepare the electromagnet, right? आपको भी एक electromagnet की device बनाना है, बराबर. उसमें ज्यादा खर्चा है ही नहीं, है ना. एक कॉपर इंसुलेटेड वायर आपको सिर्फ लाना पड़ेगा, थोड़ा छोटा सा, बराबर. वो इलेक्ट्रिक के शॉप में आपको मिल सकता है. सो मैग्नेटिक इफेक्ट ऑफ इलेक्ट्रिक करंट. टेक अ कार्डबोर्ड ट्रे फ्रॉम इनसाइड अ डिस्कार्ड मैच बॉक्स, रैप एन इलेक्ट्रिक. दिस इज द इफेक्ट ऑफ इलेक्ट्रिक करंट ऑन अ कंपास नीडल, राइट. Like this way you have to prepare the circuits. ये इलेक्ट्रोमैग्नेटिज्म बनाने का नहीं है ये एक्टिविटी, ये दूसरा है. ओके, सो प्लीज नोट डाउन. A few around the cardboard tray. Place a small compass needle inside. Now connect the free ends of this wire to the electric cells through a switch as shown in figure 14.7. Note down the direction in which the compass needle is pointing. Bring a bar of magnet near the compass needle. Observe that what happened now. While watching the compass needle carefully, move the switches to on position. Here it is the figure of or image of this Hans Christian Ørsted. Remember, this Hans Christian Ørsted, who was known as the father of electromagnetism. Correct. So what do you observe? Does the compass needle deflects? Move the switch back to the off position. Does the compass needle back to its initial position? Repeat this experiment a few times. What does this experiment indicate? We know that the needle of compass is tiny magnet, right? Itself a magnet which point in the north-south directions. So when we bring a magnet close to it, the needle gets deflected. So we have also seen that the compass needle gets deflected when the current flows in a nearby wire. जैसे करंट होगा ना, सो वो आपका जो ये मैग्नेटिक कंपास है वो उसका जो है निडल वो डिफ्लेक्ट करेगा. इट मीन्स दैट योर सर्किट इज ऑन. सर्किट जैसे ऑफ हो जाएगा वैसे डिफ्लेक्ट करना बंद हो जाएगा. सो कैन यू कनेक्ट द टू ऑब्जर्वेशन व्हेन द करंट फ्लो थ्रू द वायर? डज द वायर बिहेव लाइक अ मैग्नेट? सो दिस व्हाट अ साइंटिस्ट कॉल्ड Hans Christian Ørsted also wondered. He was the first person who noticed the deflection of compass needle every time the current was passed through the wire. So when the electric current passes through the wire, it behaves like a magnet. So this is the magnetic effect of electric current. In fact, electric current can be used to make magnets. And here, using this simple circuit, we take. Now how to prepare magnet? Now ये स्टूडेंट्स आपको करना है, राइट. एकदम छोटा सा एक्सपेरिमेंट आप घर में कर सकते हो, बहुत मजा आएगा आपको. इसमें एक आप क्या लो, यहाँ एक सिंगल सेल ले लो, हाँ, नहीं तो वो जो बैटरी आती है 9 वोल्ट की 2 सेल की वो ले लो, या तो सिंगल सेल ले लो, राइट. देन दिस स्विच वो आप सेफ्टी पिन का बना सकते हो. फिर यहाँ एक इंसुलेटेड कॉपर वायर लेना है आपको, कॉपर वायर ये इंसुलेटेड, और एक स्क्रू लो, उसके ऊपर बराबर ऐसे टाई कर दो, है ना. ऐसे कॉपर वायर इसके ऊपर बराबर ऐसे जैसे दिया वैसे टाई कर दो, और ये पॉजिटिव टर्मिनल को यहाँ अटैच कर दो, बराबर. अभी आप क्या करो, वो स्विच को ऑन करो तो क्या होगा, और थोड़ी पिन ले लो ऐसे, देखो ये पिन ले, ये पिन जैसे आप स्विच ऑन करोगे ना तो ये पिन चिपक जाएगी। मीन्स क्या होगा, यहाँ ये आपका मैग्नेट बन जाएगा फॉर सम टाइम। जैसे आप स्विच ऑफ कर दोगे, वो पिन है वो नीचे गिर जाएगी। सो दिस इज द हाउ टू प्रिपेयर इलेक्ट्रोमैग्नेट, है ना। दिस इज अ नॉट परमानेंट मैग्नेट, राइट, इट इज जस्ट फॉर अ टेम्पररी मैग्नेट. So temporary magnet that you can use by this insulating copper wire on this iron screw, right. तो ये आप बना सकते हो an electromagnet. So electromagnet activity number 14.6. Take a round 75 centimeter long piece of insulated यानी प्लास्टिक और क्लोथ कवर्ड, है ना, और एनेमल इंसुलेटेड कॉपर वायर, आपको बोलने का इंसुलेटेड कॉपर वायर हमें दो. Flexible wire and iron nail say about 6 to 10 centimeter long. Wind यानी इसके ऊपर बांधो. Wind the wire tightly around the nail in the form of coil, जैसे हमने देखा. Connect the free ends of the wire to the terminal of the cell through the switch as shown in figure. Dry cell ले लो, बराबर, उसके साथ कनेक्ट कर दो. Place some pins on or near the end of the nail. Now switch on the current. What happened? Do the pins cling to the tip of the nail? Yes. Switch off the current. Are the pins still clinging to the end of the nail? No. वो जो पिन है वो जैसे करंट बंद कर दोगे इमीडिएटली वो गिर जाएगी. So the coil in the above activity behaves like a magnet when electric current flows through it. So when electric current is switched off, the coil generally loses its magnetism. Such coils are called electromagnets. So the electromagnets can be made very strong and can lift very heavy loads that you can find in that you can find in that that crane, right. In that crane such type of electromagnet is arranged to lift the scrap of the car when it is damaged. So do you remember the crane about which you read in chapter number 13 grade 6? The end of the such crane has a strong electromagnet attached to it. The electromagnets are used to separate magnetic material from the junk, right. So doctor used tiny electromagnets to take out the small piece of magnetic material that have accidentally fallen in the eye. So many toys also have electromagnet inside them. Here you can see electric bell. Electric bell, it is also the principle, it is also working on the principle of electromagnetism. We are quite familiar with an electric bell. It has an electromagnet in it. Let us see how it works. Now you see here the electromagnet, that bell has such type of this device. Figure 14.20 shows the circuit of electric bell. It consists of coil of a wire wound on iron piece. So this is the circuit of electric bell. The coil acts as an electromagnet. An iron strip with a hammer at one end is kept close to the electromagnet and there is a contact screw near the iron strip. So when the iron strip in contact with the screw, the current flows through the coil which becomes an electromagnet. It pulls the iron strip. In the process, the hammer at the end of the iron strip strikes the gong of the bell to produce a sound. However, when the electromagnet pulls the iron strip, it also breaks the circuits. So the current through the coil stops flowing. Will the coil remain in the electromagnet? The coil is no longer an electromagnet. It no longer attracts the iron strip. The iron strip comes back to its original position and touches the contact screw again. So this completes the circuit. The current flow in the coil and hammer strikes the gong again and rings the bell. So this process is repeated in fixed succession. The hammer strikes the gong every time the circuit is completed. So this is how the electric bell rings. So here this chapter is over. Next time we will see the extra videos of this chapter and notes of this chapter. Now it is attention that students, please attention. Tomorrow will be the test of mathematics that is taken by the government. So one paper will be there. Okay, so as we have read the instructions from the group, that it is it is that instructions, in that instructions, that paper, maths paper is there, and grade 7, in that you have to prepare that the topics like that: equivalent ratio, convert decimal to percentage, percentage into fraction and decimal fraction, comparing quantities, in that calculate interest, rate of profit, loss percentage, gain percentage, right? In rational numbers, these chapters reduced to standard form, write rational number between 1 upon 2 and 1 upon 3 like that, addition of rational number, multiplication of rational number, such type of topics are there, right? So be prepared, and this exam is compulsory for all, right? Periodic assessment test, okay? तो उनको आपको सबमिट करके, उनको आपको वो लिख के पेपर, यू कैन राइट डाउन दैट दिस पेपर इन नोटबुक और इन सप्लीमेंट्री ऑल्सो, यू कैन प्रिपेयर द सप्लीमेंट्री बाय योर सेल्फ, और जिसमें वो लिखा है वैसे आप उसको नेम, स्टैंडर्ड, डिवीजन बराबर उसके बराबर लिखना, ओके? एंड you have to submit me before 4th January, right? तो बिफोर 4th January वो मुझे सबमिशन हो जाना चाहिए, आपको पीडीएफ भी भेजना है, राइट? अंदर लिखा ही है, राइट? सो एज पर दैट इंस्ट्रक्शन यू हैव टू फॉलो, ओके? सो हैव ए नाइस डे, ओके? थैंक यू.